Okay, we should probably start this meeting. This meeting is going to be a general meeting, which in order to update you guys about the progress for the whole Ausdroid student group, what we did in this semester, and also talking about the future plans, including the schedules, the important days. And I'm Guang. I'm currently the president of this student club. So let's take a look on what we are going to talk in this meeting. So the first, we are going to introduce the general stuff, the general task about this student group. And secondly, I will let the hardware team talk about the hardware, the progress on the hardware team, and also their plans in the future. And then we will talk about the software team and plans. So let's begin. In general, the Ausdroid team in the 2020 semester 2, we mainly focus on 4 tasks. The first one is we are trying to exploring between different projects. So as you all know that this student club is built mainly focused on the ICRA AI challenge. So basically it's a test related with design autonomous agent. And as you might know that the key point, the major task in this contest, in this challenge is about the programming. So it's about the agent design, the computer vision algorithm, the localization algorithm, and also some other experiment design. However, since we are working with a robot, so we need to have a hardware team. So the purpose of the hardware team for the AI challenge will be maintain the robot itself, and also design for the sensor, the connector for the sensors. However, we think it might be slightly unfair for the hardware team. So we are trying to figure out whether we can tackle other contests which will benefit both software team and hardware team. So we were looking at the mathwork mini drone competition. Basically, it's using the embedded system to design a mini drone fly follow lines and so take off in a certain position, follow lines to the target position, and then take down. And so, however, this mini drone competition is very easy. So we are thinking about something close with our robot. So that's why we're choosing the Robot Master University Technical Challenge as the second direction for the hardware team. So in the technical challenge, it will be contain both software team and the hardware team's efforts, but mainly focus on the hardware team because they will build their own robots. And I will let the hardware team to introduce details about this competition. So that's what we explore in this semester. And secondly, we have our annual general meeting. So basically, this is required by the GSA, and it's like updating of the whole committee. In this year, now we have more than 100 members, and which means we will have more funding and we will host more events. And we had our annual general meeting, I think 2 weeks ago, which you should all receive an email about this meeting happens, and also about the available position you can apply. And this is our committee for the year 2020, which is me, Murphy, and JC, and Jeremy, and Mia. So we thank all the members for their contribution in the 2020, and wish wish them good luck in the future. And after the AGM, now our committee become those 4 members. So I'm still the president and team leader, and also the Murphy is the vice president who in charge of the research and development, and he also in charge of the hardware team. Yeah, he also acts as an advisor for the hardware team, and myself is the president, and I'm in charge of the software team. And we got 2 vice presidents, which is Yu and Yiran. So one is in charge of executive task, and another one is in charge of the publicity task. So this is our new committee for the 2021. And then the third thing we are going to talk about is moving. So as some of you might know, our base was in the building DMD room 6.15. And however, that building was going to change its purpose. So we were in the CIS department, but the CIS is moving. So we are going to be in the new building across the street. If you might know, it's the old place of hospital. And now the new building is finished. We are going to move into the Telstra Creator Center, which means more space. And it's a pretty open space. So as long as we book the space, we will have pretty large space for the development and testing. Much better than the DMD 615. And the last one is the projects. So in the 2020 semester 2, we have 2 groups doing the computing project and one group doing the research project, and also some other students doing non-subject related projects. So that's the overview of what's happening in the 2020 semester 2. And now I'm going to pass to the hardware team to introduce their progress. So stop sharing.
Hi, everyone. This is Ming Liang from Hardware's group. Me and Jessica is going to talk about our recent progress and plans. So, oh, sorry. Yeah. So as Guang has said, to better practice our skills about hardware stuff, we have decided to form a team and register in RMUT, which stands for Robot Master University Technical Challenge. And this competition is divided into 3 projects: standard racing and smart firing, engineer mining, and dart targeting, which we're not planning on participating in this season. And oh, okay, should make, oh, sorry. Minimize this window. Okay, and this picture on the right is the competition site, which I will talk in detail later. And these 2 robots are the robots to finish the project. This one is the engineer robot, and this one is the standard robot for standard racing and smart firing. And this is me. I am the team captain of the competition, RMUT, and this is Hui Zhang is our team manager. So now I'm gonna talk about the standard racing and smart firing project. This is the competition site. And it is 8 meters wide and 10 meters long. During the competition, the robot will start at zone A and move to zone B, then glide across. See this arrow? It will glide across this gap and land before zone C. Then it will pass zone C and finally arrive at this logo area to shoot at it's called the power room. When the power room is hit, the competition finishes, and the team finished the competition in the shortest time will win. And knowing the task in the competition, let's take a look at the subsystem of the robot. There are four subsystems. Three of them traces, firing device, and gimbal or hardware, and one computer vision software. The first one, traces, is the base of the whole robot, and so obviously control is involved in this subsystem, like microcontroller, motors, and all those things. And also because in the competition, the robot will kind of fly here, so it requires the suspension system, like these springs and damping, showing in this picture. So for the requirements for the suspension is to no, the purpose of the suspension is for soften the landing of the robot, and also the chassis should be should be light, so it won't hit too hard, and also have a low center of gravity. Otherwise, the robot might tip over when it lands. Second, the gimbal, it should have 2 degrees of freedom, which are yaw and pitch, because it need to point the gun at the target, the power room. Again, control system, the gimbal should react fast to the command sent from the computer vision software, since the target. Oh, I forgot to talk about this. During the competition, this power room will be rotating in random direction, and in a varying speed. So the gimbal should respond fast to be able to follow the motion of the power room. And also, the gimbal should not be too heavy, since heavy mass leads to large moment of inertia, which will reduce the response speed. Will slow down the speed, the response. Sorry. And third, firing device. The rule of the competition states that the robot can be preloaded with 50 ammos at the beginning of the competition, so it should be able to carry that many of ammos. And the bullet should have a stable ballistic trajectory instead of wiggling in the air like a knuckleball in soccer. Further, the motors for shooting out the bullets should maintain a high shooting speed. That means after each shot, the speed of the motor should not drop too much. And last, speed control. I guess that's kind of overlapping with the Formula 2 control things. I will not talk too much. And last one, not least, computer vision software. It will do 4 things: detect the power room, and calculate the rotation speed and direction of the room, measure the distance, and decide when to shoot. So next, the next project is engineer mining. This is the competition site. It shares the same competition site with the formal project. Sorry. The robot will also start from zone A, and then it moves to this place. It's called Resource Island, to pick up minerals. And pay attention here, number 5 here, it is a 90 millimeter ramp. So that means this robot should also have a suspension system, which I will talk about later. And after the robot pick up the minerals, it will go to the exchange station and put the minerals on top of the station surface in this area, this little blue square. And the station scans the barcode at the bottom of the minerals. When it succeeds, the robot should push the mineral into the mineral container. There are 5 minerals in total, and the robot is allowed to carry multiple minerals in each trip. Here is the dimensions of the minerals. There are cubes of size 200 millimeters. And here's about the robot. Similarly, for systems and the requirement for chases is pretty much the same to the previous project. But only one thing, it don't need to handle that extreme of a situation, like hitting the ground. And second, the robot arm. The preliminary design is that the robot arm has 5 degrees of freedom. Although we are in the start of this season, so it might change. And it's able to pick up the minerals as well as flip them. Because at the beginning of the competition, all the minerals are held over the surface of the resource island. They will start dropping to the island surface after 10 seconds the competition starts. Because the minerals will drop, the mineral surface with the barcode is not necessary at the bottom when it stands still. So the robot arm will flip them and face the barcode downwards. The control for robot arm is more complicated than the last project, like the gimbal. It involves some reverse kinematics trajectory planning. And also, the robot arm is not able to should not be too heavy. And third, mineral container. The mineral will not drop to the resource island surface at the same time. So there will be 2 rounds. 2 minerals drop in the first round and 3 in the second round. So here, only the maximum capacity of the mineral container should be able to hold at least 3, not 5. Plus, it should also prevent the mineral from bumping out during the transportation. And last one, software. The software will detect the minerals and calculate their relative position to the in the robot base coordinate. The position message will then be used for trajectory planning to deploy the robot arm. Yeah, now here's everything about the hardware competition RMUT. Any questions? Yeah, you can just turn your mic on and ask. None? All right. Now let's welcome Hui Zhang, Jessica, to present the rest. Thank you.
Okay, let me share the screen. Wait a minute. Okay. So, hi everyone, I'm Hui Zhang, and let me introduce the season schedule for RMUT. So according to the official field, here is meaning concludes 3 official deadline. So before the end of the May, we need to have a complete form of our robots. And according to this, our plan we plan to have a basic design before March and around 2 months time for optimization and maintenance and sorry. Maintenance. It's important to note that this is just a summary plan, and we will make a specific plan according to the actual demand. For example, the mechanical group in our team should design the mechanical arm, while the programming group need to spend time on learning official open source code. And another deadline is about the task of writing feedback reports, and this task will be happened at the same time. And finally, the competition will hold around August. The official haven't gave the specific date until now, but they need us to submit a season summary in the middle of August. And this thing is the season schedule. Next part, I will introduce our team organization structure. So far we have 10 team members, and the team can be divided as three, actually can be divided as 3 departments based on the function. But as we can see here, just show 2 because the last department is responsible for the sponsor and the other business plan. So which means all team members are in this department. And so if you have any business resource, welcome to introduce for our team. And we haven't divided our team members to this technology group, but we plan to divide our team member as 3 technical group as mechanical, electrical, and programming. The divided will consider the team members' opinion, but also will consider the personal skills. For example, like a person who wanted to go to the mechanical group, but the person is more good at the embedded programming, so maybe the team member will divided to the electrical group first. So that's all for our team structure and the season schedule. Any questions? Any question? Or if you have question later, welcome to ask us at any time. So I will stop the sharing. So Hu Guang, hello?
Yes.
You can continue.
Okay. So let's let me share my screen. Can you guys see my screen?
Yeah.
Okay. So now let's introduce the updates on the software team. As you all know that this semester the university campus is closed, so we have to do all the developing online, and so we have 2 major directions in this semester. One is the the computer vision, and the second one is the simulation environment. So in the simulation environment, we successfully built the robot and built the robot model and created the competition field. And now the robot is able to move in the field and also show the camera movements, and we will demonstrate that later. And about the computer vision, we have two computing project team which work on the software development project, which is Team Koala and Team Wombat. And we also have one research project team. So the focus on the computing project will be implementing several, I think, maybe one computer vision algorithm, for example, like YOLO, and try it with the images and try to make a reasonable, easy use the GUI with it. And the focus on the research team will be try different algorithms. So this guy, I think the guy from the research team try 4 different algorithms and try to compare between the performance of each algorithm. And next is I'm going to give the screen share to share screen to Isaac, and he's from the Team Koala, and he will do a quick demo on their product from this semester. Stop.
All right, so should I share the screen, right?
Yes. Yes, please.
Okay, right. Can you guys see my screen?
Not yet. Yes. No.
No? Hello?
Yes, we can see our screen.
All right. Okay, hello. My name is Isaac. I'm from Team Koala. I was part of a team of 5 people. So we developed this GUI to like compare different algorithms for computer vision to detect the armor of the robot, to do like object detection and pose recognition. So we just implement one algorithm, which is YOLO V4 Tiny. And so basically, this is our area where we have the photo. We work with images the whole semester because we couldn't like have the contact with the robot physically. So this is the image part. In this top part, we have some our buttons, and in this part, we have our output data. So if we go to file, then we can upload the images that we want to detect the armor and the pose. So let's say, well, this one I think is the same. Okay, so if we click run, then our implementation is able to identify the armor of the opponent and saying like this is the red one and this is the front armor. And this is the confidence measure, and the output data is here. So we output the pixels where the armor is located, the pose of the robot, uh, yeah, the speed and the image frame name. So if we want to upload a batch of images, we can do it as well. So let's like select all of them. This is not. The GUI is built on Python. We use tkinter as the GUI development framework. All right, so the the images that they are already uploaded. So if we move this slider, we can see the movement of the robot. Like this is a video split it in different frames. So if we run the algorithm, it will take a while because we do it in the background and then we generate the images again. But in the field, the robot won't need to do that, right? Because the robot is just the only matter is to identify the armor and the pose. The robot doesn't need to generate the images again, but we are doing it here because it's just visualization stuff. Oh, sorry. Let me connect the computer. It's gonna turn off. Okay, so the algorithm detect the images, sorry, the armor in every image. So if we move, we can see we are detecting the greatest one, or the one that is like in front of the camera. And for every of them, any of them, we are saying like this is a blue one, this is the front armor, and this is our confidence. So we got this the back, the side, and the front. So another scenario would be if we have more than one robot in the field. So this is a made up image. We didn't have this image in the data set. We just made it with Photoshop. So if we run it, then we are able to identify all the facing armors. So in that case, maybe a new development layer will say like, okay, we are the blue one, but we won't uh, shoot to the red one or the red two. So like in this part, the robot should like choose where to shoot, but the robot already know where exactly is each armor. So this was pretty much our progress. Thank you.
Thanks, Isaac. Uh, I think there are some other stuff behind your demonstration. You can have like 3 model to serve for different purpose, like to recognize all the armors and or to try to recognize the bigger one or the armor with the same team. So pretty impressive stuff in one semester, I think. And so thank you, Isaac. And I'm going to share my screen now. Yes. Can you guys see my screen?
Yeah.
Okay. So beside the team Koala, we also have a team Wombat. Basically, they're trying to do the same thing, and they also try the YOLO algorithm, but they try YOLO V3, and the GUI, which looks similar, but the problem is the speed of the YOLO V3 is slightly slower than the YOLO V4 Tiny. And the second progress we had is related with the simulation. So simulation is very important because without the real environment, how can we test our algorithm? How can we test our agent? We have to use the simulation environment. And I think WebBeam is the guy who in charge of doing the simulation environment and entering the robot models. And since she is having an exam right now, she cannot do the demo. I'm going to do the demo for her. Let's see. So basically, so for the current progress, we are still working with the Unity, but we are trying to move to another environment, which is called UE4. So compared to the Unity, the UE4 is more flexible and has more functions, and also user-friendly. You can use GUI for a lot of programming stuff. So you don't have to manually link your classes together. You can use GUI to do that. And as you can see, Yeah, I think you all can see. As you can see, this is a computation field, and we already updated based on this year's computation field. And another very interesting thing is this computation field is not built inside the Unity, which means it can easily transfer to other platform. So basically, this whole thing is a big item. We can import this item in any simulation environment. And the second thing is the robot. I'm not sure whether my computer, oops, what did I do? I'm not sure whether my computer is able to show you guys the details of this robot. So pretty much it's really, really detailed. So you can see each of the objects inside it, and also we have the light bar and also the number on the robot armor board. So basically, it's like a recreation of what happened in the real life, real environment. But there's a difference between the real one and the simulated one. Is the light bar. As you can see in the simulation, we cannot really afford to do the light on all those stuff, which means in the simulation environment, the color blue is not light, but the color is still blue. It's just there's no light from this. And later on about the future project, I will tell you guys what's we are going to do with the simulation with the CV project. And let's do a quick demo on the current capability of this simulation environment. Let's see if it works. So as you can see, this is currently it's a first-person view of the robot, which is supposed to be the camera the robot sees. And currently the camera is moved based on the mouse movements. So if I put my mouse down, as you can see, the camera can see the robot itself, and in front of you is a lidar. It doesn't really matter. And if we move it on the right, you'll be able to see right in the simulation environment, and the left. And also I can move around, like moving forward, moving backward, moving side. And so basically that's the current capability of this robot. And I think that's it. Any questions so far on the progress of the the CV project and the simulation project? Any questions?
Yeah. Actually, I don't have a question for the progress. I have a little question about the simulation
Yes.
simulation environment.
Yes.
This you're using Unix? No, Unity. Yeah,
Yes,
Unity.
Unity.
Is this similar environment like the gazebo in ROS?
It's different. So the gazebo is built on built for the purpose of robotic simulation. So it's user friendly with ROS. And the problem with the gazebo is it's too precise. So a lot of movements of the drawing is not necessary in the computation, in the how to say that, in the building of the simulation environment. So for example, like for your robot engineering robot, which you need to uh, move
Oh, you
around
mean
the
the
blocks using,
engineer mining robot?
yes, your mining robot.
Yeah.
So that one is more suitable to build in the gazebo because it's request specific movements of the joint.
Oh, I see.
So this one we focus on the bullet shooting. It's pretty hard to do that in gazebo. So that's why we choose Unity, or we choose other game engine. So because it's more like a game than a robotic simulation.
Oh, okay. Thank you.
No worries. So any other question related with this? No? Okay, great. Then let's move on to the next phase. So the next phase is we are going to introduce the schedule and also the future plans. The schedule, it will look like this. So at the end of this year, which is 25th of December, we will, it's a deadline for the technical proposal. So as you all know that this competition is hosted by a Chinese company, we don't really have Christmas there. So that's why the deadline is look like this. And this technical proposal is optional. So, and why I'm saying it's optional, because we already got the discount price to purchase the items we need to use in the competition. So one goal to writing this technical proposal is to get the discount, so which we don't really need that. And the second one is to have the to be eligible to purchase the AI robot, which we already got the AI robot. So for this year, we don't really need that. And why I'm still listing here is because it's a good opportunity to get feedback from the host. So if you write this and send it to the host, they will provide some feedback, so you know whether you are in the right direction or not. So that's why this is optional over here. And the second guideline is the technical report. This is extremely important because this will determine whether we can enter the final competition or not. And in this report, we will have two things. One is a report. The second one is a demonstration video. So basically, we write everything we have implemented in on the robot into the report, and it will have a formal template and a structure on the game rules. We don't really want to go to details because this is a general meeting for both software team and the hardware team. So later on, we will have maybe next week or after next week, we will have detailed meeting on the hardware team and the software team separately. And in the report, beside writing the report, we also have to record a demo video to show what we are writing in the report is actually can be done by our robot. So that's the purpose of the video. And the deadline for this is on the 26th of March, which means we approximately have 3 to 4, I think 4 months for this. So from my past experience, I think we are currently on schedule. So we're still on schedule. And another very important day is entry list announcement, which is a result of the technical report. So it will be on 1st of April. At that time, we will know whether we can enter the final competition or not. And the challenge will be taken around May to June 2021 in China, Xi'an. So I think it's a historical and a beautiful city. So it will be a good experience to attend if you have time. And that's the important date. And the last thing is the future plans. So what are the plans based on our current progress? There are two directions. There's still two directions because even if the registration, the restriction of the COVID-19 is getting loosened, but the university's policy is still off campus. I'm not sure when university will be open. They say around March something, but we need to work on the simulation and the survey first. And whenever the university is open or we can get access to the robot, we will be able to have a complete algorithm to test on it directly. So we won't be wasting time on waiting for the robots. And so the two directions, one is the simulation, which is extremely important one because we have to finish the simulation to do the future future project on the autonomous agent design, which is the AI part. And another two direction is the CV. As you can see, we already got a pretty good CV with the current image. We want to test the image from the simulation environment. So like we use the same method to mark the picture and to use a similar model to train it. And we need to test whether the performance is similar as what happened in the real life. And the second one is we are going to try to implement the CV in the Linux system. So which means we can deploy the algorithm on the robot directly. And that's for the computer vision. For the simulation, what we still need to do is we need to finalize the computation field. For example, like adding the collision detector, which means my armor will get hit, I will lose some of the point, or the opponents will gain some of point. We need to capture that. And the secondly is the referee system. Basically, it's telling the robot when to start, when to stop, and what are the current buff on each position. So that's the future plan for the future projects. And I know some of you have already taken on the CV project in this semester, but you haven't finished because you didn't enroll in the subject and you don't have enough time. That's totally fine, but you still have to, you still need to finish your first task, which is training a very basic model. And after that, then you can talk with me and work on the later project, for example, like test with simulation image or implement it on the Linux system. And so if you have, do you guys have any question based on the current plan or the progress or the future direction? Whatever question you have, you can feel free to ask it here.
So I have a question. So can we run like do you see things I see it it is like Linux system, but can we do this on Mac OS or something else?
So if you
based on Linux.
Yes, if you only working with the simulation, like finalize the computation field like this, which basically means you are working with Unity. So you can do it on Windows or the Mac. And if you're doing the CV1, which is test the image from the simulation, that also can be done with different operating system. But if you try to implement the algorithm on the robot, then you have to work with the Linux. So the current simulation system you can see over here is I'm running it on the Windows machine, but we can still use other system to access this.
Okay.
But eventually, when you have to work close with a robot, you have to use a Linux machine later.
Okay.
But that's for the later stuff. You can focus on those two for now. So any other questions?
No, thank you.
Sorry, Wang.
Yes.
When you say other projects AI, which kind of AI projects do you mean?
So it doesn't really matter like what kind of AI system you want to implement, but as long as you have a working version, you can like test it with others. So similar thing as what we did in AI subject, you write your own agent and test it with others. But
Okay.
we need the simulation environment to do that.
But that's for the navigation?
No, not only for the navigation. The navigation is already done, and so we already got our current navigation algorithm. There are several team works it in the previous semester, so it's working. The navigation is working fine. It's not perfect, but it's fine. It's can solve the progress. So basically, it's trying to tell the robot where to go, what are the position you want to go at the current moment, and whether you want to shoot at others.
Okay.
That's the AI system.
Yeah, I have another question about the navigation.
Yes.
On what kind of simulation environment will it be run?
All of them. So currently, our navigation system working with a 2D simulation called Stage, and a 3D simulation called Gazebo, and also working in the real environment. So we are expecting it will also work in the Unity as well. So same algorithm working every environment. So basically, simulation environment is a replacing of the actual environment.
See. Thank you.
No worries. So any other questions? So if you are interested in any of the project, just send me an email. We will like have a personal discuss over those projects. And if you don't have any questions, then I think that's it for today's meeting. And the rest of the time, I'm going to let you guys to talk with each other if you want. And I'm going to stop the recording.